Okay, part 2 of Git advanced tutorials, and in this tutorial I will be talking about some basic Git features, and at the end we will touch on some advanced features. So in last video in which I talked about the advanced internal concept of Git, and that video was actually really hard to follow. I will be not going into depth that much, but we will still be touching on some good topics by the end of this video. So let's get started with some basics. In Git we have three type of areas, three type of staging. Like the basic area where we work on, by area I mean the basic we are working on, we are writing code in that directory. That is our working area. If I am working on a code in this working area, then Git will have no idea about this area. So all the files in working area will be untracked. So Git is not tracking those files. Then we have something called staging area. So at staging area, Git is actually tracking those files, but these files are still not committed. So commit is our last area, which is our repository. So this is final stage. So commit simply means the snapshot of our code. Like if I have version 1 of my code and I commit that code, and Git will take a snapshot of that code and store some metadata like history and when that commit was added and all of that extra stuffs. And then if I add some new features in my code and make another commit, Git will again take the snapshot at any point in time, and I can see in logs at which time what type of commit I made. So this is all part of the repo, the final stage. In staging area, Git will just keep track of the files which will be added to the next commit, and in working area Git does not track those files. So just to clear that point, I will be demonstrating all of these areas one by one. So if you remember last time we made a repo here, there is nothing in this folder, so I will be making a file. Let's name it, let's make it full screen, and this folder is empty. I'm making a file.txt. Okay, so I will be writing some gibberish here. Let's write my channel name, and now I have a file. Just assume this file is a simple code you have written, which is really important, and you want to make this to staging area. Right now we are still in our working area, so this file is okay. So the another file is just this vim created a file. There's nothing you have to worry about, just ignore that. And we just have single file in our working area, and now I want to make it to staging area. But maybe this file is already in staging area. I know it's not, but in case where you are working with a big project, how you will make sure what is the state of staging area? So we just run git status, and it will show us what is state of our staging area. And it is saying that this file.txt is still untracked. So this is not in our staging area. So how to make it to staging area? We just run this command git add and the name of the file, which is file.txt in this case. And now our file is in staging area. If I again run the same command git status, you can see that now the color is not red, it's highlighted in green color. It means it's in staging area, but still it's not committed. So Git don't have a snapshot of this code. To make a snapshot, we just commit this file. And so to do that, the command is really simple: git commit -m and the message. So we can remember when we again see in logs when this file was committed, we can see, okay, this was the message. So this helps with debugging. If we stuck on some conflict in the future, then this type of message will help us to debug. So let's write anything. You can write anything here, any message which will help you in future, and I'm just writing initial commit here because this is our first commit, and now this file is committed. If I check git status, you can see it says nothing to commit, working tree is clean. Okay, so this was really basic, but now you have a complete idea of all three areas. Right now our staging area is clear, you can see here, but it's not completely clear. By clear it means it is a copy of last commit. By clear staging area we mean that there is nothing changed from the last commit we have made. So we made no changes from the last commit. So staging area is actually not clear, it is exactly same as the last commit. So consider the baseline staging area as being an exact copy of the latest commit. We can not only just add files to the staging area, we can remove and move files as well. For example, if I want to remove a file from the staging area, I have committed a file to the staging area, and when I want to remove that file from the staging area, the command is simple: git rm for remove and the file name. And if I want to rename the file, for renaming we don't have rename function, we use move function. If I move a file from one folder to the same folder with different name, then it will be renamed. Yeah, I know, weird concept, but this is how it works. If you have ever worked with Linux terminal, you already know this. So the command is git move and the file. Simple. Okay, so to add files to the staging area we use git add and file name. But if there are multiple files, if I have like 20 or 30 files and I want to add all the files, doing them one by one is not the best thing to do. So an alternative is to just use dot. We should not use that because in some cases you might add some file to the staging area you don't want to. So but if you are sure that you want to add all the files to the staging area, then you can just do git add and dot. It will add all the files to the staging area. We have nothing to add here, so I will not run that command. But if you want to add all the files but you want to do that manually one by one, so if you want, like, terminal ask you if you want to add this file or not on each stage or for each file. If I have 10 or 20 files, then I can run just git. If I have 10-20 files to add, I can just run git add and -p. If I run this command, git will ask me one by one if you want to add this file or not, and I can just answer yes, no, or I can. And there are multiple features also available with this function, like I can say if I want to rename this file or something, if I want to edit something in this file. This all can be done by this command. This is really simple to use and really useful to know. So I hope by now you have a complete picture in your mind how content moves in the Git. So just to clarify, we have a working area where we code and a staging area which stores the file which will be included in the next commit, and then we have commit which have a snapshot of our code base. So that's all you have to know about how content moves in the Git. Okay, let's talk about something else. Git branching. In Git we have a feature like we can create a branch, we can fork a branch and started working on that in parallel. So what I mean is that this is my code, this is the timeline of my code, and it is going like that. And at this point of time, a developer, so my work code have, so I'm working on a project and there are 10 or 20 developers working on the same code base, and this complete project is open source, and we all developers are working on that, and we are making commits in this timeline like this. And a developer think that he want to add some features, but it is not relevant to our product, so he fork a branch. he just created another branch with the same code base and started working on this. So he started working on this branch for some time, added some new feature, and sometime in future we decide that let's merge both of these branches and start working together again. So when we merge both of these branches, all the features of this branch and all the features of the master branch will come together, and it will create this single branch which have all the features of both branch. There can be multiple branch, there is no limit on that. So this is called forking, where you create another branch of yours when you create another branch of the code base, and this is called the merge, when you merge branch and create one single branch. Okay, so let's try to do this. So let's create another branch. So this is my feature branch and the branch is created. And now to switch to that branch, right now I'm not on this feature branch. My current branch is still the master branch. So how to check which branch you are on currently? If you are using Git's own terminal, so if you have Git installed, just right click and you will see Git bash here. If you are in Git bash, it will show in brackets here which branch you are on, but I'm not using Git terminal. So how to check which branch I am on in this terminal? So I will just get the file. I have already in my first video I talked about .git folder. In .git folder we have a file called head, and the head file have reference to our master branch. So head will always be head is an pointer actually. So if you are coming from C++, you know what the pointer is. Pointer just point to the content, and in case of Git, the pointer head is pointing to our master branch. It will always point to the current branch we are on. In this case, it is right now pointing to the master branch, so we are on master branch. Now how to go to the feature branch? That is really simple. We just run git checkout and feature. Now it says we are switched to branch feature, but just to confirm we can again say .git and head, and it will say that we are on head/feature branch. So we are on feature branch. And as I say in the last video, that how Git quickly moves the content. So Git actually does not move the content. That's why this is really fast. Git actually changed the pointer. So the head was pointing to master, and it just, when I ran this command, it just changes that pointer, and now head is pointing to feature branch. Simple. Now just the staging area and everything is same here, because when we fork the old code base created a parallel branch. The code base was same in both branch. So let's make some changes. So if you are new here, subscribe to the channel, okay? And now if I check Git status, I just have one untracked file. So I'm adding this to I'm adding this file to our staging area, and now commit this file. Okay, so my staging area is clean. Now if I switch to my master branch and I check my content is not changed right here. So my content was changed in that branch only. In the master branch, the content is still same. Okay, so that was easy to understand. We have just two parallel branches and both are independent completely until we merge both of them. Okay, so I want to discuss one more thing here. So I'm making change in the master branch. The head is pointing to the master branch right now, and I'm making some changes, like just say press the bell icon if you have already subscribed. If you haven't, please subscribe first and then press the bell icon. And now Git status, and I'm removing these files. Now I only have one file, and this file have changed the content. This is still in my working area. So if you see, this is still in my working area, and if I do git status, you can see that this file is untracked. So before putting this file to the staging area, I want to switch to my feature branch and check what is the content. But what happens if I try to do so? I cannot switch before I commit. And if I try to do so, all the changes will be lost because they are untracked, and my head is pointing to this branch. When the head pointer changed, all the untracked changes will be lost forever. I don't want to do that, but I don't want to commit this file right now either. So in that case, we use something called Git Stash. So what Git Stash does is that it will create something. Just imagine a vault. It will just save all the files, all untracked file or all the staging area files to that vault, and you can switch the branches and do anything. And when you come back, you can apply that vault. I mean, you can just switch back to your previous state. So that is really easy to do, and that is really helpful to do. This is the most useful command in Git. So how that works is, like, I want to switch branch right now without making the commit. So what I will do is that I will just run git stash, and it says saved working directory and index, and I can even write my message with this, so I remember when I come back to this file. But right now, just for the simplicity, I'm not doing any of that. And now let's try to switch branch again. Git checkout and feature. Yes, now we can switch the branch. I can make some changes here, and okay, let's check the content of the file. The content of the file is same because we haven't made any change in our feature branch. It is, if you are new here, subscribe to the channel. And now let's switch back to our master branch. And now if I check the content, my content is not changed, but I made some changes here. These changes are lost, but they are not lost because we have saved all the changes in our stash. We can save multiple stash, and just to view all the saved stashes, we can run git stash show, and it shows that we have only one stash here, and we can just apply that git stash apply. And now we are back to our last point where we made a stash. We have one untracked file, and the content of the file is this. So yeah, so you can see how useful this command is. In some cases, stash might not include untracked file. In that case, run this command git stash include untracked. But in my case it was including by default, so I don't have to do that. I'm just showing this for I'm just showing this, so if you face any this type of problem, you can use this command. And if we want to include all the files, like sometimes we have some ignored file, we create a file called .git ignore. So if you are web developer, you might know that we have a folder called node modules, which have a lot of files, lot of modules, and we don't want to include that in our directory or in our repo before pushing that to the remote server, because all of this file can be generated at any point. We just have to do npm install and all the file will be installed. If you don't know about anything web development related, don't worry, I'm just giving an example so the web developers understand this even clearly. So we create a file git ignore, and in this file we just list all the files we want to ignore. So if I want to ignore node modules, I'll be create git ignore, and here I will write node underscore modules. Now git will not track node modules folder, so if I create a folder called node modules and I go to node modules folder and create a file a.txt, and I write something, like check out whole playlist of Git advanced course on my channel. So this file should be untracked. So if I do ls, you can see we have a node modules folder, but we have node modules folder and I haven't committed this folder yet. So if I do git status, it should show this folder as untracked. But if I do git status, you can see this if I do git status, git just ignore this entire folder because we have listed this folder in .git ignore file. So that is git ignore is used for that. But while making stash, if I want to include that folder as well, I can do git stash and -- all. If I run this command, if I run this command in my stash, node modules folder will be included as well, and all of the files which are ignored, all this file will be included in my git stash. As I mentioned before, you can add comments or text with your stash, so you can identify your stash in future. Like if I want to add some tag for the easy reference, I can just say git stash save and the tag or the comment like first stash or something like that. And we can even start a new branch from the stash. This is really advanced and I never used it, but you might need this. You can do git stash branch and branch name, so something like that. And there might be a situation where you have created a stash which have 20 or 30 files or something, but you don't want to apply stash directly. If you apply that stash, all the file will be in your working area directly, but you just want to check only one file from the stash. You can do that as well. You can just do git checkout and stash name. You can just reference it by the tag you have given it to your stash, and hyphen is actually separated. It says that your previous command ended here, and here you can say file name. Now if your stash is taking too much memory and you want to clean it, you can just run git stash and pop. It will not clean all the stashes, but it will just clean the last stash. It will just delete one stash. But there is a problem with this, that git stash pop will delete the last stash, but it will apply that stash as well. But if you don't want to apply that stash, you just want to delete, just forget what changes you have made, you can just do git stash and drop. It will delete that last stash and will not apply those changes. And you want to drop any specific stash, you can just do git stash and drop, and then reference to that stash, and here you put the index of the stash. Simple. And if you want to clear all the stash, you don't want to worry about anything, just clear the memory, just do git stash clear. It will clear all the stashes, delete everything, and will not apply anything to your working area. Okay, this is all about stashing. So I have talked about working area, staging area. We haven't discussed about the last repo, the commit area. The commit are actually the snapshot of our code, as I already mentioned, and commits point to the parent commits and trees. So we have parent commit. So by parent commit, I mean the last commit we have made. There will be a initial commit, the first commit we will make, which will not point to any commit. So for example, this is my initial commit, and it will not point to any commit. It will just point to the files, the various files I have created my code area, and then I created another commit. Now this new commit will point to the previous commit, and if I create another commit, that will point to this commit. So we get this graph, and this is actually a security feature, because now every commit have the SHA of all of these files, and that SHA will include other metadata as well, like the date when this was created, the reference to the previous commit. Now for example, if I try to change any commit from the past, so now for example, if I try to change any commit from the history, that will make some changes in the file, and the new SHA will be completely different. So the SHA of this commit will be different, then the SHA of the next commit will be different as well, because that commit actually depends on this commit's data. What I'm trying to say is that all the commits are connected. All the commits are connected, it is like a chain reaction. If I changed any of the commit, all the previous commit will show an error because their SHA will not match. This is a actually security feature, because now our commits are safe, because no one can modify these commits from the history. And also something happened to our local machine, like if the hard disk get corrupted, the hash will be different, and it will show the error. So we know that hash are not matching, we have some error. This same type of concept is also used in cryptocurrencies. Like just take an example of bitcoins. We have blocks which are connected with the hash of the previous last block. The Bitcoin technology especially use SHA-256 hash, which is the standard for them. In Git we use SHA-1 hash. So SHA-256 is really hard to crack, but Git actually does not need that much of complexity. So coming back to the Git, this type of commits make a graph type of structure. We can check out this commit as well. So if I do git log, it shows all the list of the commits I have made. So here you can also check the branch you are on. I'm on master branch, and the last commit is made by me, and so the last commit is made by me. So So it has some metadata like the author name, the date, and the time when the commit was created, and the hash as well. I can check out this hash. So just remember this hash. Actually, you don't have to. I will not be clearing the screen, but if I list all the files from .git folder, okay, sorry, I should do tree and .git, and this hash is starting from 95, and you can see in our object I have a 95 folder, and in this 95 folder and in this 95 folder I will have file with the name starting from the third character to the end of this hash with this name, and that file will have the content of this commit. Okay, let's check out this commit, but actually there is a problem here. We cannot directly just open that file in notepad because that file's data is compressed. So to view that data we have to use git functions. So that are really simple. To print the data of a normal file we use cat. In git we use git and then cat file, and the hash we want to print. We don't have to give reference to the whole hash, like this whole hash. I don't have to write this whole hash. 4-5 digits are enough because git only have to identify a unique hash, and the all hashes are unique. Just first 4-5 characters will differentiate them, and if I so it will not print the file. I have to, so what I need, so if I do -t here, it will print the type of the file. It says it's a commit file. So some files will say it is a blob. So if you have seen the first video, you know that the type of the file can also be a blob. In this case, this is a commit, and if I want to see the content of this commit, I just have to do -p here, and it will print all the content of the commit. So this is not a file, it is a commit, so it is not just printing what I have written into a specific file. It is giving me a tree and the hash of that tree, the tree this commit is referencing to. So as I have already demonstrated, this is our commit and it is referencing to some files. So this is our actually tree data structure, and this commit is referencing to this data structure. We can check out this tree as well. If I copy this and just do git cat file and -p, I just want to know the content because I already know the type is tree and the content will be the blob. Now the tree is giving me the blob is a specific file, and this is the file of our hash, and the file name is file.txt, and this is the mode, the permission this file have, the read write permission. So I don't want to discuss this here, but I might make some video on this in future. But if I want to check the content of the file, I can check the file here. Now we have the content of the initial commit. So I think this video is already getting too long, and that is all for this video. Okay.